loading meeting controls, and then yeah, we should be ready to use the arrows.
Oh, okay. Hi, everyone. I'm Sal, and today I am going to endeavor to track Scotch broom through the Olympic Peninsula with the use of satellite images. This, as John said earlier, this came as a partnership with the 10,000 Years Institute out in Forks. They were concerned about Scotch broom encroaching through the Olympic Peninsula and its potential effects on wildfires and their relative size and intensity. So I was tasked for trying to see if that was true. So a quick roadmap of how we're going to go today. I'm going to start with a little bit of background on Scotch broom, some of the negative effects, why it's an issue, why we're looking at it. Then I'm going to slide into methods, what I did to track it through the peninsula and what that kind of looks like, and then end with my results, what I found, how it's affecting wildfires, and then future studies that I think could build upon what I found and other things that can be looked at in the future. So to begin, Scotch broom is not a nice plant to have around. It was originally brought over in the 1850s into California as kind of a form of road erosion control. So they put it alongside or highways, and over time, it spread rapidly up the coast, either through ballistic dispersal on people's boots, in cars, and gravel, and quickly made its way up here to Washington, where it inhabits recently disturbed sites, so either places of clear cuts or construction, anything like that where humans are moving through. And once once established in a site, over the course of 3 years, it grows into these large, dense thickets in which it will then disperse more and more seeds. And over that time, it'll fix nitrogen in the soil. It acts as a sponge, just taking massive amounts of moisture out of the soil as well, making it difficult for other plants and our native species to survive, causing an increased die-off of them, leading to this buildup of litter and debris under the thickets, which is where this whole question came along was, does that increase litter and does Scotch broom being as resinous as it is increase wildfire tendencies? As you can see in this photo, all that yellow is Scotch broom. It'll help transfer fires across these open areas quicker and allow them to jump into canopies of the neighboring forest. So this way. So to begin, I was looking for wildfire polygons from 2024 to 2016. Unfortunately, I could only use I only found polygons from 2023 to 2016. Any ones from 2014 just had points and total burned area, but it didn't have a defined border, so I couldn't really use those. Um, and here are some fires from the Olympic Peninsula, and all of these ones occurred in 2023, and you can kind of see the vast difference in acres burned, with the Delaware being over 4,000 and the Martin Lake one being about 120. For the rest of this presentation, I'm going to be focusing on the Delaware fire, but know that all of my tests were done on all of the wildfires I found. So to begin, I had to select a satellite imaging program that I really liked. There was three major ones: Planet Labs, Landsat, and Sentinel-2. I started with Planet Labs because that's the one 10,000 Years Institute used, and they allowed me to get a bunch of images from, and I enjoyed using it because it had the finest resolution of all the programs at 3 meters. But the issue was the Olympic Peninsula was such a vast stretch of land. Trying to find satellite images for them was very difficult. As you can see, that's 7 tracks, and to get the entire peninsula would take about 12. And they were all from different days. They were all varying qualities. As you can see, there would be a lot of mosaicing and a lot of color correction. So I went to Landsat next because it was just one track. It was just one big square, and I could technically get a second one to get the little corner up there. But since none of the wildfires landed in that section, I didn't find it necessary. The issue is it only had 30-meter resolution, which left a lot of things blurry. And so I went to Sentinel, which had around 10 meters of resolution, which was a good middle ground where I could see things. I could, it only took three tracks, and yes, the colors are a little weird, but once I mosaicked and uh, layered them, it all evened out. Um, so Sentinel 2 is the one I ended up going with. Next, I ran all of those images through the GIS Pro classification wizard. Here's the settings I chose. I did supervise, so I went in and I was physically picking training sites. I would zoom in, look at pixels, see what was yellow, what. So Scotch broom is yellow. That's the one way I can find it on the satellites. And that was the easiest way to define it and find it. So all of my images came from April to June, which was the blooming season of Scotch broom. That's when it was the brightest and the most contrastive. I also had, sorry, I skipped over something to go back. So when I was finding my satellite images, I had to make sure that the cloud cover was as low as possible. I set all my settings to under 30%. Which quickly became an issue because April through June on the peninsula is super cloudy. So I couldn't use any of my 2016 photos because it was just white for that entire span of time. So I had to get rid of those wildfires. So it ended up being from 2017 to 2023. Um, so so in that time span, I was looking for Scotch broom. It was super bright yellow, and I divided it into these six categories: water, developed, so that would be either towns, roads, that sort of thing. Barren being just open fields of dirt. Forest is just everything else that was green. And Scotch broom, and then clouds and snow, since they were white and they kind of looked the same, I just chunked those together. At one point, I did either it was Scotch broom or it wasn't, which didn't really work because then it was just a one color of just green and it almost never picked up Scotch broom. So I found that having six categories worked better, but in a moment you're seeing how that still didn't work. So so as you can see on the left side here, those are the training sites. So what essentially I did was I just zoomed in and made freehand polygons of whatever I can see. So barren or the Scotch broom in yellow there, the forest on the side, and I did that to about 25% of the image. The images were kind of big and I didn't want to, it would take a long time to go through each one. And the end result is what you can see on the right there. As you can see, a lot of what would be classified as barren came up as developed. And this happened time and time again. I ran it 3 or 4 times trying to better isolate the developed sections, trying to make sure I was getting only buildings and avoiding like parks in towns or even, dirt sidewalks. Just really trying to focus it in. And for whatever reason, it kept pumping out dirt as towns. You can kind of see at the bottom left that there is brown, which is dirt, and it just never, I could never finesse it to get it consistently. Um, so in the end, so here's the Delaware fire again. So in the end, when I finally started overlaying my wildfire polygons, I got almost no yellow in any of the wildfires. I would see like 1 pixel, 2 pixels, something like that. The Delaware fire had 0 pixels of Scotch broom. And either there was actually no Scotch broom there or it's not noticing it. Because as you can see, a lot of that red is it's saying that's a town, which this is the top of Mount Dana, and there's no buildings out there. It kept picking up clouds as buildings. It kept picking up snow as buildings because a lot of buildings have white roofs So that was another thing I tried to avoid later on, was just not getting any roof that looked white. And it kept pushing it out as dirt as being a building. Um, so some recommendations I'd have moving forward is trying to incorporate drone imaging of it. So this drone image was taken by Mike south of Forks in uh 2023, and this was actually 2 days before the satellite images that I had earlier. So as you can see, it's the classification wizard is actually picking up much more fine details of the Scotch broom. You can see it's even picking up the road really well. And I know we can't drone image the entire Olympic Peninsula. That would be way too hard. But if we can figure out sites of recent disturbance and go scan them later, because Scotch broom takes about 2 to 3 years before it gets to a big size where we can easily see the yellow. And one of the issues with this site too is it was clear cut in 2019. So as you can see, it took a while for the Scotch broom to come back. So places like the Delaware fire, in 3 years, we could maybe go scan there, because in 2016, one of the fires I couldn't use was the Godskin fire, and that fell almost entirely in the Delaware fire border. So maybe if we had scanned that, 3 years afterwards, there may have been some Scotch broom in the drone images. Maybe it's not, but definitely something to look into in the future, which I think could help any further studies looking into the additive effects or any effect of Scotch broom on wildfires. I had originally planned to look at, if I had found Scotch broom, I had planned to look into drought, wind speed, direction, and the slope. Um, the the GIS Living Atlas has a very up-to-date drought calendar that you can see here on the left. It was abnormally dry, and that was pretty much for the entire peninsula. And then on the right, it has a slope. I was finding that the more aggressive the slope, the faster the wildfire moved, because the plume action would push the fire up quicker into the canopy. So I was thinking that that would also be an issue to look into. Wind speed and direction also plays a massive role into it, pushing fires along its track faster and almost funneling it in a way. So the highlighted portion was the wind speed and direction of the Delaware fire when it started. So that might be something included in further studies, and if I had found something, I would have liked to look into that further. Um, and thank you. I appreciate you guys being here. A lot of thanks to John and Mike for helping me through all of this. And yeah. Okay.
It's not bad.